Alright, speaking of global warming, hyperbolas have a lot to do with global warming. I'm not sure what, but they do. Alright, so let me just do one version of a hyperbola. I'll do the vertical one, so I'll make my little rectangle. I'll make my asymptotes. Oops, boy, that was terrible. Well, I don't forgive myself. It's just I should have this down on its little stand, and it would be better. Anyway, all right. My focus. Sorry, my vertex is on the rectangle. Yay, rectangles. Yes. And then I use my asymptotes to kind of get the opening up of this hyperbola. The axis that it doesn't contain, well, the axis that the vertex is on is called the transverse axis. The foci, just like with the parabolas, are inside the little bowl thing. So here are my foci. That would be the plural of focus. Okay. And the distance from the center to the focus is again going to be c. And this distance is the same on both sides. And we have our, let me mark my A is here, and my B is the other axis. I know the drawings for these hyperbolas get so complicated. Sorry. The orange, yeah, the yellow is C. The B, here we go, is there. The A is there. It's the two different ways of doing these. The A is the distance from the center to the side of the rectangle on the horizontal. The B is the distance from the center to the top of the rectangle on the vertical. And the C is the distance from the center to the focus. So C, as usual, is going to be a distance from the center to the focus. That's been consistent with our C's. And our equation for the C for the hyperbola is c squared equals a squared plus b squared. Okay? For the ellipsis, it was a squared minus b squared, or b squared minus a squared. For the hyperbolas, it's a squared plus b squared. It's the sum instead of a difference. Yes. It's always the sum. Remember, the ellipsis was the difference. The hyperbolas, it's the sum. Okay? So let's try a problem here. Let's find the focus of, we'll do something fairly easy here. X squared over 25. Going to be a hyperbola, so I'm going to subtract y squared over 9 equals 1. Going to find the focus, and we're going to make a little graph of this. So let me make a graph first. Try to locate my focus. All right. So my A is the square root of 25, which is 5. My B is the square root of 9, which is 3. My center is at 0, 0. Luckily for now, center stay at 0, 0. So I'm going to go 5 to the left and right of my center and 3 up and down from my center and make that little rectangle. I'll go ahead and make my asymptotes from the center through the corners of the rectangle. Now, this is x squared minus y squared, so it's going to be oriented horizontally. So my vertex is at 5, 0 and negative 5, 0. Let me go ahead and finish off my graph here. All right. My focus is going to be on that same transverse axis as my vertex, as my vertices. So there are my foci. So I kind of know where they are. Now let me exactly locate them. The distance from the center to the focus is going to be defined by c squared equals a squared plus b squared. So c squared is, a squared is 25, b squared is 9. So c squared is 34. So c is the square root of 34. 34 is 2 times 17, so that can't be simplified. Now that's the distance from the center to the focus, but now I need this actual point. Well, it's on the x-axis, and it's the square root of 34 from 0, so the focus point is square root of 34, comma 0. And the other focus is on the other side of the center, negative square root of 34, comma 0. That's it. Did you want to see another example of that, or are we cool? Well, so, yeah, it's the same thing we did yesterday. We just had to add in the focus. So we're